I am Dr. Jagadha, Associate Professor in the Department of Mathematics. The topic for discussion is application of Laplace transform. First, we will discuss what is the definition of Laplace transform, and we will concentrate the problems on application of Laplace transform. The definition of Laplace transform, that is, suppose let f of t be a given function. It is defined for all positive values of t. So f of t is a function where the t is playing the role. What it possesses is only positive values. Then the Laplace transform of f of t, which is denoted by L of f of t. Otherwise, it is f bar of s. Now, L of f of t or f bar of s, now here that is f of t which is multiplied by e power minus st dt and which is integrate between 0 to infinity. The integral compulsory it should exist, and the parameter, this parameter s is a real or complex number. Solution of ordinary differential equation. First, the ordinary differential equation. Laplace transform. So many transforms are there. What is actually specific or the benefit, usage? How the Laplace transform is more efficiency compared to other applications. Now, if you are taking this ordinary differential equations, d square y by dx square, suppose 2 plus 3 dy by dx. So we know it here the order is 2, here the order is 1. So the highest order is 2, the degree is 1. This ordinary differential equations with the constant coefficients to solve, we can select Laplace transform method is a very easiest and time consuming also. But if you are going any other methods, their general solution we have to find CF plus particular integral, complementary function plus particular integral. But that all it is not there while if you adopted this Laplace transform. It is a very easiest way we can find the solution for this ordinary differential equations, and this constant values also. There, if we adopt any other methods, it is very complicated and time consuming also it is there. So now, one problem we will concentrate. Solve the following initial value problem by using Laplace transform. For y double dash plus pi square y equal to 0. So one second order, this differential equation which is given here. Then y of 0 equal to 2. That is y of x equal to, at the point x equal to 0, the y value is 2. We have to read like that. Here the first derivative, because y dash it is there. So the first derivative of y, at the point x equal to 0, the first derivative of y, the value is 0. This is the differential equation. This we have to solve using Laplace transform. Now, given equation is 4y double dash plus pi square y equal to 0. We are going to take Laplace transform on both the sides. So L of, we have written here 4y double dash plus pi square y equal to L of 0, 0. Now L of 4y double dash one term it is there, plus pi square y. So Laplace transform of two terms are there. So immediately Laplace transform of the first term, that is this one, plus Laplace transform the second one we have to write. Is there any property? Yes, the property is linearity property. That is L of C1 into f of t plus C2 into g of t. That is the first one is f of t, the second one is g of t. Put together Laplace transform. So how we can write? So C1 into Laplace of the first one is f of t plus C2 into Laplace transform of the second function g of t. So L of 4 into L of y double dash plus pi square into L of y equal to 0. Now for L of y double dash, the formula we are writing, that is y double dash s square into L of y minus s into y of 0 minus y dash of 0. This formula, to remember easy way, suppose that is our given problem y double dash it is there, fine, according to that we wrote it. In case instead of y double dash, if it is y triple dash it is there, then s cube L of y minus s square y of 0 minus s y dash of 0 minus y double dash of 0. Here triple dash is there, that's what s cube we started. Suppose y fourth derivative is there, we will start s power 4. Any mathematical formula, how to keep in our mind, is there any easy way? That we have to search and we have to keep it in our memory. Because so many formulas will be there. Easy any technique is there that we have to search and we have to keep. If it is third derivative, we will start with s cube. If it is fourth derivative, we will start with s power 4. And it is going on, s is decreasing. S cube, s square, s power 1, s power 0. S power 0, the value is 1. Because according to exponential law, we know it a power 0, the value is 1. So the s regarding that is over. The first term is L of y combining. Next y of 0, y dash of 0, y double dash of 0. That is here third derivative is there, the ending will be second two derivative. If it is four derivative the question, the ending will be three derivatives. Easy way to remember. Oh, we will come back to our problem now. Our problem, y double dash it is there. That is, so double dash. We will start with s square. Fine. S square, it will be going on decreasing. That is s square, s power 1. Here s power 0. That's what it is treated as 1. We know it. Next, the first term is L of y. The second one is y of 0. Next, y dash of 0. Here, two derivative it is there. That's what we end with 1. So, n derivative means the formula ending will be n minus 1. Easy to remember. Next, the given question, pi square L of y. Now, 4 into s square L of y, this y of 0. Y of 0, the value is 2. So, 2s it is written. Here, y dash of 0, the value which is given according to the condition, the value is given 0, that we substituted. This y of 0, it is given as 2. it is given as 2, this is given as 0. Now this is pi square L of y equal to 0. Now 4 into s square L of y minus 2s, this it is written as it is. So L of y we are grouping. So here L of y, this part it is written. Here this L of y pi square is written. Here the balance one is minus 8. Here, yeah, 4 into minus 2s, it's nothing but minus 8s. The next step, minus 8s, we push to right side. It has become plus 8s. So L of y, it's nothing but 8s divided by this part here. This 4s square plus pi square. Now, this L, we brought it here. It is written L inverse of 8s by 4s square plus pi square. Now, L of cos 80. We know the formula. Here, L inverse of 8s by 4s square plus pi square, suitable inverse formula. This is inverse Laplace transform of. In the application, first, initially we are applying Laplace on both sides. The final result, inverse Laplace transform we are finding. So, inverse Laplace transform of, for this particular, so many formulas are there. Suitable for this, we have to select and we have to substitute here. Quickly, fraction of second, we have to select that formula. So the first, the target, the numerator. The numerator, s is there. Fine. The numerator, s is there. Cos, we will select. If s is not there, we will select sine. It's a small technique. That's it. So now, cos 80. And the denominator, sine we will see. If it is positive, cos 80 we will go. If it is negative, it is there, cos h we will go. Now, so we can compare to this. Here we can see it. L of cos 80 we selected because of the reason. The numerator is, it has yes. The denominator is plus sign is there. So both giving an idea, better we can select it to finish the solution quickly, perfectly, correctly. So L of cos 80 equal to s by s square plus a square. Now, this one, s square is there here, but according to our problem here, 4s square is there. We want only s square. 4 should be removed. 4 should be removed. Then this is divided by 4 we will do. Everything is divided by 4. So here 8s divided by 4, we got it to 2s. So 4s square by 4, we got it s square. Here pi square by 4. Fine. Next, this 2 we brought it here out because we want this format. This format it is there. Cos 80 we can write it. L inverse of s by s square plus a square. So we want such a format. So now s is there, fine. S square is there, fine. A square, that can be here in this place. We can write pi by 2 the whole square. So what is this? Cos 80. According to our problem, what is our a? It's nothing but pi by 2. So the answer is this 2 cos 80. Our a is pi by 2. So 2 into cos of pi t by 2. So we will concentrate one more problem. Solve the differential equation using Laplace transform. D square x by dt square plus 3 into dx by dt plus 2x equal to e power minus t. X of 0 equal to 0. x dash of 0 equal to 1. So the solution is, given differential equation is, so what is the equation which is given, which is written as it is. Now, d squared x by dt square, we can write it, x double dash we can write, 3 into dx by dt we can write x dash, this is 2x, this is written e power minus t. So we are going to take Laplace transform on both sides. So we have taken here the Laplace transform of 3 terms are there. So we know the property. Using that, Laplace transform of first plus Laplace transform of the second plus Laplace transform of third. So the property, it's nothing but linearity property. So using that linearity property, that is L of C1 into the first function f of t plus C2 into the second function g of t, which can be written as C1 into Laplace transform of the first one plus C2 into Laplace transform of second one. So the Laplace transform of two or more, any more functions can be written Laplace transform of, that is sum of Laplace transform of each can be written only possible by the property that is nothing but linearity. Yeah, fine. Using that linearity, we wrote it. So the first one, the constant, we wrote it 3 into L of x1 plus 2 into L of x. So L of e power minus t. So now here x double dash it is there. That means s square we are going to start. So s square into L of x. S square, yes. Why we selected here square? Because it is derivative 2, x double dash. So s square we will be starting, easy to remember. Then s will be decreasing. We can see it, s square, yes, s power 1. Here, s power 0. Nothing is there means s power 0. S power 0, the value is 1. Next, L of x, x of 0, x dash of 0. We wrote the formula correctly because the question is x double dash, it should end with 1 dash. That is here n means here n minus 1. Next, this one we can see it 3 as it is. Here the first derivative is there. That's what we will start with the s. S into L of x minus x of 0 plus this is 2 into L of x. This is L of e power minus t. Now this is written as it is. In the question, x of 0, the value is given 0. So s into 0, 0. X dash of 0, it is given 1. 3. This all written as it is. X of 0 is 0. Next 2 into L of x. This L of e power minus t. Now this one, s square into L of s minus 1. 3 into s L of x. The zeros and all we removed it. So L of x we grouped it. So s square plus 3s plus 2 minus 1 equal to L of e power minus t. The next step we wrote it. So we can see it here. This L of e power minus t. The formula is L of e power minus at. The formula is 1 by s plus a. Fine. So 1 by, here our a is 1. So 1 by s plus 1. So the next one is the minus 1, which we brought it here. It has become plus 1. So L of s square plus 3s plus 2 equal to 1 by s plus 1 plus 1. So we did the cross multiplication here. 1 plus s plus 1 by s plus 1. So this simplified s plus 2 by s plus 1. The next step, here we did the factorization. That is, this we did the factorization. We got it s plus 2 into s plus 1. So the next step here, s plus 2 divided by s plus 1. This complete the terms we are bringing here. So s plus 2, this both getting cancelled. So 1 by s plus 1 the whole square. Yeah, now the x, this L is bringing here L inverse. Now L inverse, that is inverse Laplace transform of 1 by s plus 1 the whole square. Easy way, 1 L of e power at minus. Why I selected minus? Opposite we know it. Minus a means plus a will be 1 by s plus a. So e power minus a t, it's nothing but L inverse of s plus a. Correct formulas we should select. Here only s plus 1 is there. It indicates s plus a is there. So s plus a related which formula? L of e power minus at equal to 1 by s plus a. L is moving this side. L inverse of 1 by s plus a. So what I am going to do, this plus 1 is there. That purpose, L inverse is nothing but e power minus t. The balance is 1 by s square. Next, e power minus t, we want it, here L inverse should be L inverse of 1 by s square. That is, L inverse of 1 by s square we want it. Immediate formula, L of t power n, it's nothing but n factorial by s by n plus 1. That is t power n equal to L inverse of n factorial by s power n plus 1. According to this here, 1 by s square is there. So we can see that formula only it is written. So we can substitute L of t. It's nothing but here formula substituting 1 factorial s power 1 plus 1. It's nothing but 1 by s square. So t equal to L inverse of 1 by s square. It's nothing but t. So we will come to a conclusion about this topic. That is first actually why we have to select this Laplace transform for the application. Because if you do any other method, we have to adopt a complementary function and particular integral. Those steps are to be done. But Laplace transform, which is the very easiest way. And we concentrated the first problem. And the second problem also we concentrated. And the steps what we followed, we have taken Laplace transform on both the sides of the differential equations, and where it is required linearity property we applied it, and what are the conditions are given that we substituted, and we got an equation, and we did the grouping, and finally we applied inverse Laplace transform and we solved it. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.